Hi, my name is Nick Howes. I'm the lead research and development specialist for a rather large defence company based in the UK in the Space Strategic Initiative team. I also work there as a test analyst, testing software for various defence projects. And I'm also the director of Aerolite Meteorites in Europe, one of the world's largest commercial meteorite companies. And part-time I also work as a science writer for a variety of magazines, and formerly was with the European Space Agency in science communication and also with the Square Kilometre Array. And what I'm going to talk to you about today is a little project that my company is currently working on that came from an idea I had almost a decade ago. So around about 2010-2011, NASA were working on a range of updates in the Mars landers, what's now the MSL project, Mars Science Laboratory on the surface of Mars, roving around doing its fantastic work. And they were looking at ways that they could improve some of the science coming back from it. And one of the things they were looking at during the EDL, entry, descent and landing phase, was some things called balanced mass weights. Now these are quite heavy weights, about 75 kilograms, that are jettisoned during the dangerous EDL phase when the spacecraft is entering Mars's atmosphere. And they're literally just thrown away. They're just weights that are used to kind of adjust some of the balance aspects of the spacecraft during its entry into the Martian atmosphere. And they're just large weights. So I had this idea of replacing those with a scientific package. And this is where the concept of what's now known as MEDIAN was born. So MEDIAN stands for Methane Detection by In Situ Analysis with Nanolanders. Everyone loves a good acronym in the space industry, and that's where that one came from. So the idea with MEDIAN was that during this EDL phase, these science packages would be deployed into quite high atmospheric altitude and kind of drift down to the surface. That was the original idea anyway. And what they would do would be, inside the landing ellipse, they would land on the surface of Mars and then deploy very simple methane sensors and a kind of communication system. And the idea would be that they would communicate both with each other and with the main lander, so a rover, and they would detect the amount of methane being emitted percolating through the Martian soil, because a couple of years before that, astronomers at the Canada-France-Hawaii telescope and also the European Space Agency's Mars Express had detected, or started to detect, and this was ongoing over the following years, methane. Now the thing about methane is it's got quite a short lifespan, typically decays in a few hundred years, and this kind of prompted scientists to start thinking, well, what was causing these methane emissions? Now there are both non-biological and biological processes which can cause them, and now with some of the recent data we know that Mars is still geologically semi-active. There's some Mars quakes being detected, so there is some geological activity still occurring on Mars, but Mars has obviously got very large volcanoes in the Tharsis region, largest volcano in the whole solar system in Olympus Mons, so it's not kind of beyond the realms of possibility that these could be geological processes causing the methane, but it's really exciting to think that it could be non-geological and biological processes causing the methane, microbial life beneath the surface of Mars, because obviously on the surface of Mars itself pretty much nothing could survive. It's incredibly cold, dry, arid, almost no atmosphere, so to speak, apart from the one that causes a few problems when you're trying to land a spacecraft at high speeds. But this was kind of where the MEDIAN idea came from. So these micro landers would disperse, drift down to the surface, that was the original idea, and then radio back to the main rover where the highest concentration of methane was. And the methane sensors were being developed and improving all the time, so even though the quantities were in the parts per billion, really microscopic amounts of methane were being detected, I believed it could be done. So I, at that time, was heading over to the United States to a conference in Tucson, Arizona, and during the course of that conference I met up with a guy called Peter Smith, who was one of the principal investigators on one of the Mars spacecraft, and I was talking to him about the idea, and he was a little bit hesitant. He said, well, is there really methane on Mars? Now, obviously, we know that there is, but at the time, it was still quite a hot discussion for debate. So I had this idea of these boxes, and I talked to various friends about the idea, and one of them, a lady called Dr. Jane MacArthur, she recently completed a PhD in Martian meteorites. She was looking for a project idea, and she pitched this. So we put in a proposal to the Royal Astronomical Society, and she pitched it as an idea to take to a test site in Morocco to do further testing on the whole concept. Now, the landers were basically very small, kind of Raspberry Pi Arduino sized computers in small boxes with gas sensors, and they were placed around in the Moroccan desert by an analog astronaut. So they do lots of simulations. It's the Austrian Space Forum that run these amazing expeditions to try and test new concepts, and one of the concepts that was picked was this medium one. So Jane took the idea out there. And we had some success with that. They weren't allowed to use methane, so we had butane canisters buried beneath the desert, and the kind of idea and the concept proved to work. It was very simple experiments, but with some help from a guy who now works at JPL with some coding, we got the system to work. So I was at this conference in America, and I was wandering about, and I'd heard about this Australian guy who was there, who was kind of a bit of an entrepreneur and a bit of a space geek, but seemed to know a lot about high altitude drops and balloons and what have you. His name is Robert Brand, and Robert has an amazing history. So he's very modest about it, but Robert effectively worked on everything on the Apollo program from Apollo 11 onwards. So whilst he was in high school, he was asked to wire up and help some of the systems at the Paddington, I believe it was, comm station, which was linked directly to some of the telescopes that were communicating directly with the astronauts going to the moon. And on the basis of that, he then went on and worked on several of the other Apollo missions, and then kind of worked in that field for many years, up to and including Giotto. And he's one of the people that kind of saved the Giotto spacecraft. That's his real claim to fame, as he calls it. But really nice guy, really funny guy. Anyway, so first time I met Robert, he was actually talking to Buzz Aldrin, and it was a really amusing encounter, because I walked up, and everyone at this event is kind of looking for astronaut autographs and what have you, and I wasn't. I'm just not. Doesn't really interest me. And like the Apollo guys, are great. I've got to know many of them as friends, and they're really smashing guys. But it was Robert I really wanted to talk to, so I kind of walked up and said, "I really need to talk to you." And Buzz thought I meant him, but then I said, no, it's actually Robert I need to talk to, and it was quite amusing, actually. Anyway, so Robert and I got chatting, and we started discussing the whole concept of this Mars lander, and very quickly Robert said, well, the lander idea and the idea of using either parachutes or balloons isn't really going to work with something this small. They explained some of the reasons and rationale behind that, and I thought, okay, this guy really knows what he's doing. So we kind of sat at the bar, we had a few drinks, and we were talking with some different ideas, and literally on the back of an envelope almost, he drew out this idea for what's called penetrators. And penetrators basically are like small rockets that hit the surface really, really fast. I mean, we're looking at 300 meters per second. And I initially didn't think this was possible, but then there's been various attempts at this. The Moonlight project, which was a kind of collaboration between various UK science and research institutions, was designed to land such penetrators on the moon, and the Mars 96 spacecraft had various penetrators on it as well. None of these have ever worked, because unfortunately the missions were either cancelled, or in the case of the Mars one, it didn't even make it out of low Earth orbit, because the Russian spacecraft had some anomalies. But the concept is solid. The concept itself is really good, and a company in the UK called Kinetic have proved it. They did a lot of testing for another mission which was proposed to Europa, where they were slamming these projectiles into blocks of ice at 300 meters per second, and the science packages on board survived. So we did some work and concepts in collaboration with them on some other ideas that we were looking at, and it turns out that this whole concept of slamming something into the surface of Mars could work. So Robert sent the idea off to various people, including people at NASA, and they loved it. They really thought it was a great idea. We got letters of support back from them. and we now have an amazing team of people involved in this. So we're now in the phase of rocket testing and launching and doing high altitude drop tests. We're a team based in the United States. We've got the backing of people like Neil Armstrong's son, Rick Armstrong, who is part of the team as well, loves the idea. Two quite famous astronauts, Nicole Stott and Jerry Ross, who are also part of the team. We've got some great people all over the world working on this. And it's a really exciting prospect to think that potentially this could help solve this mystery and work out whether or not there is life on Mars. And I for I'm really proud to have instigated the idea and done some of the initial work. It's been some amazing work done in computational fluid dynamics by students in the UK as well. It's been amazing, a really amazing journey, and I'm hoping, fingers crossed, that maybe in the next 5 to 10 years, if a mission would like to have the median on board, that they'll take it and we can be part of the quest for life on Mars. On that note, I'd like to say thank you, and I hope you enjoy the rest of the lockdown.